Okay, so we're going to be talking about some rules or properties for definite integrals, and they're actually really nice, so I'm just going to review them. The first one deals with an integral when you are going from one number to itself. So in this case, if you notice here, it says from a to a. Well, remember, the integral is the area under the curve, and if you are looking or examining from one point to itself, then there is no area under the curve. So it makes sense then that the area under the curve is 0. Now, integrals are also additive. So if you have, for example, an integral from a to b, and then it goes from b to c, so then it's possible then, when you add them, to go from a to c. And so that's what happens there. They are additive. Same thing goes for subtraction. It works the same way. Okay. The order of integration. Notice here the limits of integration swap places. You go from b to a. And if you go the alternate route, a to b, they are equivalent. However, they are opposite in sign. So this is where you get this negative in front of the integrand there. All right. The constant multiple, if you multiply by a constant right in the front, just like that, k, well, you can factor it out. So if you know the integral from a to b of f of x dx, you just multiply it by k then. All right. Same thing goes if you have a negative number. All right. So you can pull out that negative number. So k can be any constant and it could be a negative. All right. They are totally additive and subtractive. What does that mean? If you look at them in isolation, as long as the limits of integration are the same, as long as it goes from a to b for both, you can add and subtract them. And that's what this is telling us right here in this case. All right. So that's a couple of properties there to look at. The next thing that we're going to note here are the sum and difference. Okay, well, no, we already talked about that, sorry. The maximum and minimum inequality, it's as if maximum function and minimum function are I'm sorry, not function, but values on the interval. Then the following inequality is satisfied here. We're not going to really discuss this much, but just consider that this is referring to maxima and minima of functions. All right, and we've got the last one on the domination. So we're talking about if a function is greater than the other, so then it makes sense that the integral of one would be greater than the other. Okay, not much to it there, but we're going to go ahead and take a look at a few examples here. So give me 1 second to display those on the screen. Okay, so let's take a look at the following examples and how we can apply these properties. And I'm going to call them properties, okay? And we'll reference them as we're working out these problems. So number one, pull that back up on the screen real quick. Number one says, suppose that the integral of f of x from 3 to 5 is negative 4. Okay, so the area under the curve from 3 to 5 is negative 4. The first one says find the integral from 5 to 5. Well, that right there is property number 1. That is property number 1, and property number 1 says if you go from a to a on an integral, you end up with 0. All right, so the integral there is 0, and I'm going to write that, and I'm going to write that this is by property number 1. All right, and then look at the next one. What about the integral from 5 to 3? Well, we were going from 3 to 5 earlier. So if we go from 5 to 3, like this, well, that it is property number 3, the order of integration property. And that says that you take the opposite sign of the area. So if it was negative 4, it becomes positive 4 in terms of its area. Okay, so if you change the direction of which you're integrating, the area becomes the opposite sign. All right, not much to it. And again, we're going to write this one as property number 3. All right, so not too bad here. Let's take a look at number 2. Number 2 says, suppose that the integral from 5 to 6 of the function f of x is 7. All right, so we are we are asked to find, and it looks like this got distorted, so let me go ahead and fix it for you. We are asked to find, in this case, let's see what that integral is. It is the integral from 5 to 6 of 8 times f of x dx. That's what it's asking for. So this one right here, if we look at our properties again, this one is the constant multiple rule. So we will end up factoring out this 8, and we're going to multiply it by the integral that was originally given, which was 7, and 8 times 7 is 56. So this one right here is true because of property number 4, the constant multiple rule. All right, nothing to it. And now we're going to take a look at the next one. It says from 5 to 6, negative f of x. So again, this one's still the constant multiple rule, property 4. So we just take the opposite sign, in this case, negative 7. So again, this one is negative 7. And again, by the same property, property number 4. All right, and now let's take a look at the last example. It says, suppose that f and g are continuous, and the integral from 6 to 10 of f of x is negative 6. And the integral of g of x from 6 to 10, let me fix that, of g of x is 9. So this one right here, they're asking us to do kind of a constant multiple rule. So I'm going to make my note here that this one right here is property number 4. And then I see that they're being added. So this one right here is property number 5, which is the sum and difference property. So I'm just going to make those little notes here so that you can see what properties we're using. But otherwise, we are good to go. We're going to say 4. The integral of f from 6 to 10 was negative 6. So 4 times negative 6 plus the integral from 6 to 10 of g was 9. So 4 times negative 6 plus 9, that gives us negative 24 plus 9, which is negative 15, our final answer. So some really nice and simple problems here. Again, we're given the integrals already, so we kind of just work and apply with the properties, if you will. All right, nothing to it. Again, those properties, really nice to review. So please go over those. I hope this video was helpful. And remember, like always, like and subscribe.